Well, thank you so much for having me here today. I'm super thrilled to be here. I'm a KCD organizer myself, so I think we should start by giving the organizing team a big round of applause. I know it's a lot of work putting an event like this together, so they really deserve all the love from you. So, so today I will talk a little bit about from signals to standards and how we can unify platform engineering and observability. I also want to take a trip down memory lane just a little bit, talking about what Kubernetes gave us and sort of compare that to the observability space and how I see that today. And hopefully I will be able to do a demo. We'll see how that goes. It's always interesting. Haven't sacrificed anything for the demo gods, but we'll see how that goes. And let's just get started. So let me just remove this one. So my name is Kasper. I work as a developer advocate at Dash0. We are an OpenTelemetry native observability platform, fairly new, launched in November last year. And I joined the company in January. I came from a role as a platform engineer at a company called Lunar in the Nordics, which is a challenger bank. So I've been building platforms for 8 years there. I'm also a co-founder of the Cloud Native Nordics, which is a meetup alliance across the Nordic countries, Sweden, Norway, Denmark, Finland, and Iceland. And we are basically trying to help each other across the Nordics around creating great meetups and spread the word around Cloud Native. I'm also a CNCF ambassador. I know there's a few ambassadors here as well, so that's awesome. I spent some time before KubeCon trying to catch up with all the CNCF certification. Last year, they announced this Golden Kubeastronaut program. It's the 13 CNCF certificates plus a Linux Foundation system administrator one. And I was part of the inaugural class that was announced at KubeCon this year as well. So if you have any questions around some of this, just find me throughout the day and ask me. Yeah, I think that's a little bit enough about me. So let's talk a bit about Kubernetes and what Kubernetes gave us. And if we rewind a few years, deploying software was a little bit different, right? You might remember SSHing into a specific machine. We had manual provisioning of VMs. We had a lot of bash scripting going on. We had Jenkins, something around config management with Chef. It was a different world back then. And basically ops hold the keys to production, right? I think that was this wall where we threw software over and ops deployed and all of that. But then Kubernetes came and provided us with some great APIs, YAML, the whole promise theory, the way of declaring an intent and then a reconciliation loop going on, and all of this was just became a lot better. We defined some standards, we defined how to run and manage containers at scale using Kubernetes. And of course, the container itself was also a standard that was really, so it's all about open source standards. And I imagine it being something like this. Back then, I wasn't around. I sort of graduated right at the top of when Kubernetes came out, so I hadn't really had the experience of running this, but this is how I imagine it being. And I guess Kubernetes is more like a Zen moment, right? But I don't know, if some of you were before that time, you probably know better than I did. But if we also pause for a second and look back at KubeCon 2019, Brian Lyles had this great talk around Kubernetes complexity. So Kubernetes was introduced, right? But Kubernetes came with a lot of other issues, other problems. It just created a bunch of other problems. And the complexity grew and grew and grew. We also saw that everybody was scaling. The demand for software also skyrocketed. So complexity just grew. And Kubernetes was hard. So he really strongly talked about finding the Kubernetes Rails moment. I think we hopefully all know what Rails is. It's really about making it easy to run and build applications. And we needed to find that moment for Kubernetes as well. I think that platform engineering is somewhat kind of the movement towards Kubernetes Rails moment. And he also had this great quote that I also really loved. Back then, we were also doing a lot of things at Lunar around finding out how do we actually expose Kubernetes to our developers, how do we build abstractions on top of Kubernetes, how do we manage that complexity. And Kubernetes is really a vehicle taking us to our destination. It's not really the destination itself. I really like that, and that really resonated with what we were doing at Luna back then as well, trying to make it as easy as possible for our developers to deploy and run their software at scale. But, oh, sorry, the but was on the next slide. But Kubernetes was really the catalyst, and I think platform engineering really took this further. It gave us a lot of things, right? It gave us self-service experience. It gave us these explicit and consistent APIs. It provided these paved paths, or at least defined this is how we can deploy and put things together to obtain this Rails moment for Kubernetes. And the goal is really make it as easy to build, deploy, and run your applications in production and at scale. And basically just have your teams be as fast as possible and deliver software as fast as possible. So, show of hands, how many in here are building platforms that are following somewhat of these principles? Okay. So still a lot of you are at the before Kubernetes slide. No, but I think that what I really want to talk about here is that I think this moment is still not being really found in the observability space, because in the observability space, we still have like fragmented signals like logs, metrics, and traces that are different signals. And it hasn't really followed the same journey. So developers are still left to figure out everything on their own. They write custom instrumentation. They try to wire logs and metrics and traces together. And when something goes wrong, it's hard to figure out where is the root cause and how to actually get back to and figure out what went wrong. So it takes a lot of time. And that's not really how observability should work in a modern system, because now the complexity, again, as I mentioned before, is just increasingly growing all the time. So we need to find the Rails moment of Kubernetes. We found that. Observability. And observability is fragmented. As I mentioned before, we have these three pillars, or we've been talking about these three pillars of observability for a long time: metrics, logs, and traces. They are different tools, collect different signals. It's a sprawl of different vendors. They don't talk to each other. Developers have one browser tabs for logs, one for metrics, and one for tracing. So you could also call this the three browser tabs of observability, right? And that's not really the way we want to need. And with the system and compute we have today, we would like to have that combined and be able to do smart things across these different signals. So we don't actually have a metrics problem either, right? We actually have systems problems, which is, I think that's really powerful, because we need to be able to correlate that. We don't have specific signal problems, we have systems problems. And observability is often fragmented, and this leads to multiple challenges. One of them is that across these different signals, we have different tools with different complex query languages. So you as a developer need to understand three different query languages in order to actually do this. We have vendor login. It's really, really hard if you use a vendor's automatic instrumentation, run that in your clusters. It's hard to move to a different solution if you want to, if you're not happy, or if they're increasing their costs, as is the problem in the observability space right now. It's super expensive. We have metadata inconsistency across these signals. Uppercase, level, debug, error. It's hard to correlate across the different signals, and really that's it's unreliable, and it's really hard to figure out how to go from one system to the other when we have this inconsistency. And then, because of all this complexity, instrumentation is in some places not being done, which of course leads to other problems, that you don't have the insights and the visibility that you need in your systems. So we are lacking unified insights across the entire system. We don't understand the system as a whole. But a shift is happening, and it's a shift toward correlating these signals. It's a shift where we are trying to figure out how can we find the related information. So you have, you might come from a metric that are going beyond the threshold. That's sort of the initial step. How do you go to the traces that are happening in that time frame, to the logs of what went wrong? What did my application actually do? and that allows you to reconstruct the chain of events. This is really what we are seeing in the observability space right now. We need to figure out how to correlate these signals. This is just an example from Dash0, how we do it, just showcasing that this is a trace, and in that a specific span, you can see that, hey, that's a log event. You can see all the logs from that particular trace, and you can jump between the signals, which is quite nice. And it makes it easier for us to dive deep into the specific paths of the software. So that shift is a shift towards standardization, and it's a shift towards standardization in the collection area or the collection space. And OpenTelemetry is really what is driving that standardization. OpenTelemetry is many different things. It's all of this. It's a collector. It's instrumentation. It's auto-instrumentation. It's all kinds of different things. But as you can see at the bottom, it's about generating and emitting. It's about transmitting. There's a protocol for how to transmit telemetry, how to collect, convert, route, process, do all kinds of interesting things, and then transmit it to some kind of backend. So I think we are seeing a push right now where we are pushing all of the vendor space further down the stream. So now they're competing about how to make the analysis tool be as possible, as the best possible solution for you to actually go down and investigate these things. There's also a movement in this space around, do I need like a separate log database and trace database and metrics database? That's a different thing. That depends on the vendor and how you stitch things together. But it's a shift towards OpenTelemetry, and it's really a movement toward better observability. It's one agent to rule them all. And as my colleague at Dash0 is saying, it's the OpenTelemetry collector will be the last observability agent you will ever install. Because now you have that, you have the collection is a standard, and you can really just point it to wherever you want to point it to. And in fact, OpenTelemetry is the second largest project in the CNCF by contributor count. So as you can see up here, it's just besides Kubernetes. It's really impressive. The project update they did at KubeCon in London, they also mentioned the project is now over 80 repositories. Thousands of companies are contributing. So it's really, really an active project, and a lot of things are going on in this space, which is quite amazing. So why OpenTelemetry? It's really these four things. It's really, really, really powerful. First, it lets you instrument once and use everywhere. So you do the instrumentation, you collect the telemetry, and you can send it to whichever backend you want to send it to. That's really up to you. You can send it to multiple backends if you want to do that. Second, it separates the generation of telemetry to the analysis, as you saw on the previous slide. So we are pushing this down the stream for vendors to fight in a different area. And it also put the vendors on their toes, because now they really need to be on their toes to actually build a product that you want to use. And third, it's also make software observable by default. A lot of libraries, frameworks, projects are adopting OpenTelemetry. So when you pick some package, it will be auto-instrumented most likely, and you'll just get it out of the box. And I'll show you that in a second. And it improves how we use telemetry by connecting these dots and the different signals, as I mentioned before. So platform engineering, we had these 6 principles. We can sort of correlate that into the observability space. So for the self-service part, we have auto-instrumentation, which means that you as a platform engineer can create a platform that allows your developers to just deploy their code, and they will have auto-instrumentation out of the box. They don't have to do anything. It will just generate the telemetry for you. The consistent and explicit APIs, that is something in the OpenTelemetry project called semantic conventions. It's a standard for what we are calling different things like HTTP status code or whatever it is. There's a convention for, I think it's 90 or something different areas. So it's really a big I think it's a repo of all things you could imagine. That's a standard for how to define these things. Golden path, build observability in, make it as easy for developers. They don't have to do anything. There should just be one way to do it. Modularity is about the collector, the OpenTelemetry collector. It allows you to really stitch together how you want to send your data, which kind of information you want, and where you want to send it. Platform as a product is really about treating observability now as a product as well, and really try internally to have like good documentation support and all of this. So I think there's a lot of similarities between the platform engineering that we saw for Kubernetes and to what we are seeing in the observability space now. And I want to focus a little bit on the self-service part as well. The OpenTelemetry project comes with the OpenTelemetry operator, which if you are a platform engineer, you can take this and run it in your clusters, and you can get auto-instrumentation out of the box. It comes with this instrumentation resource that basically allows you to auto-instrument these different languages, so Go, Python, Ruby, .NET, Node.js. It will inject whatever, it's dependent on the language, but it will inject the auto-instrumentation for you, and it will send it to a collector, and it will forward it to whichever backend you sort of specify. And that I will show you in a second. But before that, I also want to talk a little bit about dashboarding and monitoring as code, because observability doesn't stop at instrumentation, right? We also need to visualize our metrics and our traces somewhere. And this is where another CNCF projects come into the picture. Perses, it's a sandbox project, and it's what they're really trying to do is standardizing how to do dashboarding. And what we are seeing in this space is that a lot of vendors are now also starting to adopt this as a standard that makes you, as an end consumer or end user of this, it makes you able to take your dashboards and move them to another vendor as well. Again, the power of open standards. It comes with like Perses dashboard resource, a Perses data source, a few things, and I'll show you that in a second. Yeah. So I think we'll try and go to the demo and see if hopefully everything is working. So I will just mirror my screen. Just clear this. Hope the size and the font size is okay. Everyone can see? Yes. So what I have right here is a Kime cluster running on my local machine. I have a few things in here. I have the OpenTelemetry operator, as I just mentioned before. I use that operator to deploy a few collectors, and we'll come back to those in a second. I have the Perses operator, which operates and manages Perses and the Perses resources. So Perses up here is managed by that operator. I have a few services. I have a to-do application written in Go and a to-do application written in Java that uses some databases underneath. And then I have Prometheus for my monitoring, and I have Jaeger for my tracing, or for my traces. So what we'll try to do is auto-instrument these two applications without touching the code at all, without having anything in the code that specifically instrument or tell that this needs to be instrumented. But before that, let's just quickly have a look at the OpenTelemetry collectors resource, because that is another thing that the OpenTelemetry operator comes with. It allows you to manage and scale your collectors as well. Oh, let me just do it like this. In this case, I have two running. It's really up to you how you want to do this. The operator supports every constellation of how to run this. You can also run the collector as a sidecar, but in this case, I run the collector one as a daemon set for more node-specific telemetry to gather kubelet data and stats from there. And I have another one deployed as a central solution as a stateful set right now, which is talking to the Kubernetes API, getting cluster-wide information and stuff like that. And I use the telemetry operator, OpenTelemetry operator, to deploy these and manage these, which is super nice. Yeah. So let's have a look at the actual services. So let's take this. Oh, not this one. Sorry. Oh, it's Hotel. There we go. Just quickly show you how the configuration look. If you're not familiar with OpenTelemetry, I know there's a lot of things in here. But basically, it has this config where you define where to send the data. You can add some extensions around like authorization and stuff like that. You can add processes for doing specific processing. In this case, I think the most important one is the KDS attributes, which is basically getting Kubernetes information for all your different data. We have the receivers, which are the probably the most interesting things. In this case, the kubelet stats is a receiver that talks to the kubelet and gets information from that. And then we expose some OTLP endpoints where our applications can actually send that telemetry to. And OTLP is the OpenTelemetry protocol for how to send and transmit telemetry data. You can also do, if you're familiar with FluentBit or something like that, or file log stash or whatever, you can also file log receivers, basically doing the same thing as you would do with FluentBit or other things like that. And then I think the cool part about all of this is that you define pipelines for each of your signals. So for logs, I want to receive OTLP, I want to receive file logs, and I want to do this processing, and I want to export them to somewhere. And the same for my metrics, and the same for my traces. It's really simple and easy to understand what's going on. And if that is an issue, let me just find the right tab. You can go to OTelBin, which is an open source project that we have created at Dash0. But you can really take your configuration and put it in here, and then you will get it visualized as well. It's quite nice to see, and you can actually validate against different distributions of the telemetry collector. It's just a nice way to sort of see what you defined and where you are sending things. Cool. Back to the demo, because I think I'm running pretty close on my time. Great. So let's have a look at the actual application. It's basically just a REST controller that you can add to-dos, create to-dos, delete to-dos, update to-dos. But what you should note here is that there's nothing specific in here around instrumentation, anything like that. It's basically just Spring Boot. Spring. I'm using the Spring Boot framework for this. It's super easy. And in order to instrument all of this without touching this code, we need this instrumentation resource that I mentioned before, which looks like this. It basically defines the exporter. So in this case, I'm sending it to the exporter of the collector that I just showed you before. So that is where the data will go. And then it will end up in the pipeline that I showed you, and it will go to, in this case, for traces to Jaeger and for metrics to Prometheus. You can do some different configurations in here. You can specify sampling rate for your sampler. You can add a lot of different stuff, and you can have language-specific configuration if you want that. I have something for Go, because Go is a little bit special in this case, as you need eBPF as a sidecar to actually get the auto-instrumentation working. So let's just apply this. Instrumentation. Great. What you now see, let me just clear it to get it on top. Get paths. Is nothing really happened. Nothing changed because this is an opt-in. You need to, as a developer, opt into this. You can, of course, build all kinds of automation in your Argo pipelines or whatever to inject an annotation because that is really how this works. So let's just do that. Let me just find the actual annotation that I need to put in. It's basically just an annotation, as you can see here. Edit, deploy, to do. Start with the Go one, and we go down to the pod template. We add an instrumentation. There we go. So what this basically tells the operator is that I want this is a Go source, inject Go, the Go auto instrumentation in this. And for Go, again, there's a little bit specifics because I cheated a little bit and added this one as well. It's really needed for the eBPF to know which binary is actually the one that should be instrumented in this case by the eBPF. You'll see that in a second. Great. Let's do the same for Java. There we go. Annotations. We will just, it's very simple. Inject Java instead. And let me clear again. Get pods. And now you'll see stuff is happening. Narrow. Yeah, there we go. Always narrow, right? No, but now you see it restarted the application. And if you noticed before now that the Go one actually has two. It has a sidecar container that is the eBPF sidecar to get the auto instrumentation out of Go. If we quickly describe, it's hard to type. Describe this one. You will see that it actually did a lot of things. It added all of these environment variables. I think for For Java specifically, it's the Java tool options that is the most interesting here. It's calling the Java agent. So there's an auto-instrumentation Java agent that is now being injected into this application. And it comes in through this init container that is managed by the OpenTelemetry operator. So that is how it works. Cool. So now we want to see that it actually did auto-instrument something. So if we port forward, as we say, to do Java 3000, we will just. So I guess this is, we need to buy some hotel swag, or we need to buy some, I don't know, Palinka maybe? Let's just do a check and see if we have everything. I think I'm running low on time, so I'll skip the Go one. But it's the same thing. So now we have, send a few requests to this application. And if we go to Jaeger, just refresh, you can see now up here in the service, if you're not familiar with Jaeger, this is the UI, this is the cool logo and everything. And we'll find some traces. And you can see now we actually have traces for the application without touching the code. It's quite nice, and you get a lot of information actually. So you get, of course, if you're not that familiar with tracing, you get the duration of the span. You can see the entire chain. You can go in and you can actually see that it interacted with the database. What query did it do? All kinds of interesting information out of the box, not touching any of the code, which is quite amazing. I guess at some point you probably have some more custom requirements or something like that. You probably opt out of auto-instrumentation, but it's a really, really a good way to get started and get things rolling. So yeah, that is really how it works. Last thing I want to show you is, of course, Perses. And for Perses, we have this data source. So for Perses, you define a data source. So Perses was for dashboarding. So this is how to actually get a dashboard up and running based on the information that we just sent through the collector. You define a data source. In this case, we're just defining where our Prometheus is. So it's pretty simple. Let's apply that. Okay, apply Perses Prometheus data source. And then, of course, we need a dashboard as well. So Perses, I have a JVM metrics dashboard. A lot of YAML here. Sorry about that. You can write Perses in Go and Q as well, but I just chose YAML in this case. As you can see, it's a Perses dashboard resource. You define different panels, charts, and then you do some queries, and then you basically just do your dashboard. And then at the end, down here somewhere, you define a grid, and you basically just lay out your dashboard. It's of course easier to do it in Perses and then export it as you would, I guess, do with Grafana as well. I think we haven't really solved that problem yet of how to actually build dashboards in code that works. Yeah, but it's quite nice to have it as a declarative format. So let me just quickly apply this. Great, and I should go here, localhost 8080. This is the Perses. This is the Perses server. This is how it looks. It has a concept of a project. You can see the data source was created. You can see a dashboard, JVM metrics was created, and we have some metrics. It's quite nice. But the cool thing about this is not how this looks. You shouldn't really. This is not the cool thing. This is the standard that the vendors are now starting to use. And if we as vendors can really agree on this standard, it's becoming really, really powerful for you as end users. So that was the demo. I have 2 minutes left. Let me just quickly go back to my slides. There we go. Demo time. Let's recap. So this was what you saw. 2 applications, Go and Java. Go uses eBPF to do the auto-instrumentation as it is right now. It comes with some trade-off in terms of security. I did a blog post on this a couple of months ago on the Dash0 blog, so if you're interested, go read that. But yeah, I used the operator, I used the collector to send data to Prometheus and Jaeger, and then we have the Perses operator to manage Perses and really get monitoring as code and dashboards as code. So the goal really is that having observability as a paved path, just as we had for have for our applications, and basically have everything auto-instrumented out of the box dashboard, clarity defined, coming from the repos or from a central place. That's really up to you how you want to do this, and not copying things over and having 15,000 different dashboards, which is horrible to manage. So let me just skip these two because I'm running out of time. So observability is evolving right now, and it's evolving really, really fast. OpenTelemetry is standardizing how we are collecting data, telemetry data. Dashboards is Perses is sort of standardizing how we should do dashboarding, and hopefully more vendors will come to the space as well. Right now it's us, Chronosphere, and a few others as far as I know. So I think this is going to be very, very powerful. And applying these platform engineering principles can transform observability from an afterthought into a seamless, scalable, and developer-friendly experience. And again, observability is a systems problem, not a tracing, not a logging, not a metrics problem. And when we connect these signals together, we empower developers to solve problems faster. And with that, I think I just hit it on time. I really think there's some cool similarities to what happened in the Kubernetes space and what is going on here. And I think we should really, really strive to build on these open standards. It's really the best thing as end users to have the vendors compete on other things, and we should definitely focus on this, and of course open source. So if you want to test this out, the demo is available on GitHub. You can find it there. And with that, thank you so much for attending.